Okay, this is video number 2. We're going to be classifying matter. This is just to get some terms under our belt. Some of this we already know. We just want to clarify how things work. Make sure we're talking about the same stuff. Okay. Remember, we're thinking particulate theory, so we're going to come at this with the idea of particles and how the particles are relating to the structure. Okay. Get some terms under our belt. Matter, this is basically anything I say has mass, occupies space. That's a really good definition there for us. Um, right, basically anything. Air, water, table, you, physical stuff. You have some sort of interaction with it. You can manipulate it. That's not a good word. Well, you get what I'm saying. All right. Substance is right, substance. This is a piece of stuff. A very generic definition. Substance just means the specific thing that we are dealing with. So it's a glass of water, it's a reaction that's happening, it's a piece of paper, it's whatever individual thing we're talking about. Okay. When we're talking about classifying matter, we're going to come at this from two directions. Some of this you may already know. Um, some of this might be new. We're just going to kind of get us all together here. Um, First off, by state, this deals with how the particles are interacting with each other. So this is about relative position and interaction uh, between particles. And it's important to note this is also temperature dependent. Good Lord. Okay. And you'll understand what I'm talking about in a sec. The other way through this is composition. Not really other way, but it's the other side of describing things. Composition deals with the types of particles. Okay. Are there uh, different different things mixed together? Are they all the same thing? Uh, can you separate them? Can you break the particles apart? That kind of stuff. Okay. Uh, so let's dive into this. State, we mean solid, liquid, gas. This is what we're talking about. And I think hopefully maybe a lot of us already have an idea of solid, liquid, gas in our mind. What we want to think about though is remember that the particles are constantly moving. Okay. So even though the solid is sitting there, it's the particles in there are vibrating and they're locked together. Okay. Um, we can also think about the interactions of stuff. So the solid particles are held together tightly. Those are stronger interactions. The gas is mostly empty space. The particles are moving faster. There's less interaction. So on the gas side, this is less interaction. On the solid side, this is more interaction. Okay. Um, Another good idea we want to think about here is that uh, gases are compressible, right? They're mostly empty space. And so you have control over the space. You can squish them together. You can let it free flow out and apart. Uh, it all works. Okay. One thing we want to consider when we're thinking about state is come at it with the idea of identifying its shape and its volume in terms of whether they are definite or indefinite, or rather constant or changeable, right? So a solid would have a definite shape and a definite uh, volume. Liquid has a definite volume, right? Because a gallon of water is a gallon of water, whether it's in a jug or a beaker or poured on the floor or whatever, it's still a gallon of water. So the volume is the same, uh, but the shape is going to be different because the liquid can flow. Okay, so it takes the shape of whatever container it's in. Um, Gas is indefinite on both accounts, right? Because the particles are freely moving. The gas will take the shape and completely take the shape of the container and completely fill the container. So, um, yeah. And the fact that it's compressible means we have a variable volume. So, and we'll talk a lot about gases towards the end of this semester. Where's my, okay. In terms of composition, this is a little bit hairier, but we can sort of work things out. Um, we have a flow chart here. We're going to think our way through it. If your matter is composed of only one kind of particle, then we can say it's a pure substance, right? Pure substance, right? One type of particle. Okay. Um, which means that, uh, yeah, all the particles in the sample are the same, right? We have two kinds of this. One of these are elements and one of these are compounds. Elements, we're not going to be able to separate them chemically. We'll talk in Gen Chem 2 about how we can separate them nuclearly. Yeah, that's a word, nuclearly. Um, but yeah, the cheat way to think about elements is that they are on the periodic table. So this is a periodic table. There's one of these in the classroom. You'll get some in class as a handout. Okay. You can find them everywhere. Uh, if it's not on the periodic table, it's not an element. So that's kind of the best way to get through that. Right. Elements are just, an atom loose by himself. Okay. When we think about compounds we can separate chemically. So we'll be able to do a chemical reaction and split them into elements or turn them into different compounds as we do that. Um, right? They're made of different elements stuck together. Okay. Um, but all the particles are still the same. So all of these water molecules are identical. But if we do chemistry on them, we can separate them into different elements as we do it. Okay. The flip side of this is if we say, okay, no, our matter is not just one type of particle, it is more than one, then we have what's called a mixture. And that term should make sense. This is multiple things that are physically mixed together. Okay. And the classification of the mixture is whether or not it's how it looks to the viewer. Okay. So we can have something that is a homogeneous mixture. This has uniform composition. So this is things like salt water, or you dissolve sugar in water, or whatever. Here, their example is a cup of tea. It looks the same. You can't see the sugar, you can't see the tea molecules, you can't see the water. It all looks the same. Okay. Um, Another good term for homogeneous mixture is a solution. This will come up again and again, but I want to make sure I throw this at you early so we get that under our belt. Solutions are homogeneous mixtures, right? Air is a mixture, right? This is uh, oxygen, nitrogen, some carbon dioxide, some argon, whatever, some water, right? But you can't see it. You can say, oh, there's an oxygen over here, there's a nitrogen over there. It's all mixed together. Heterogeneous is the opposite of this. This is a non-uniform composition, which means you can find individual pieces and you can see them. I like to think of this as the Italian salad dressing model, right? You can see the chunks, you can see the spices. If you let it sit there, the oil and the vinegar separate themselves out so you can see the different individual pieces and you can pick them apart, right? All right. Uh, One key thing about a mixture, though, is that you can physically separate the things that are mixed together. These are just different ways to do that. This is the chromatography example. We'll do that a lot in organic chemistry. Here we have sand mixed with iron filings. I need a better color. The iron is magnetic, and so the iron gets pulled up to the magnet, and the sand is left behind. So you can physically separate this thing. This is a distillation. right? For separating two different liquids that are mixed together. We'll do that a lot in organic chemistry, right? Making coffee is a physical separation. You're pulling stuff out of the coffee grounds and making it into liquid deliciousness. Okay. So this is a good summary sheet. I want us to remember that homogeneous mixtures are called solutions, right? Think of examples. I want you to look around, uh, things you come in contact with every day. Think about, is it an element compound? Is it a mixture? Is it homogeneous? Is it heterogeneous? Is it a pure substance? And could you classify things uh, that I give you as pure substance or uh, a mixture? Right. I'll catch you on the next one.